Hello, 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 hello. Good morning, everybody. Happy Wednesday. No, wait, what am I saying? Happy Monday. Happy Monday, everyone, and welcome to Office Hours. Welcome to Office Hours for Unit 1, Data Science. Hello, hello, everybody. How are you? I see all sorts of people in the chat already. So good to see Emmanuel, Jared, Karishma, Tatam, uh, Giogi, Tiger, David, James, Tanfan, Wallace, Shitsanshu, Jahangir, Ayagul. So good to see everyone. Hello, hello. I see people from Benin, India, Nigeria, Qatar. So good to see everyone. How was everyone's weekend? Wow, so many countries here. Azerbaijan, Algeria, Bangladesh. I hear it was a festive weekend in India. Glad to hear that. Let's open up the chat so that everyone can see. I had a very good weekend. Thank you so much for asking. Uh, non la non halana, excuse my pronunciation. Good weekend. Very exciting. I had a good weekend. Thank you, Wallace. Lots of relaxing. I was trying to learn some linear algebra, get better with that. So did anybody get work done during the weekend? Any work done for the for our course? Unit 1 students, how did you do? Surav has a great question, a great place to start the office hours for this session. They want to know that will they become a data scientist after this course? Well, I would say that you will be on your way to being a data scientist after this course. You're going to have a good foundation. So maybe you're not 100% of the way there, but you'll have a good base that you'll be able to use for your continued learning and education and work. So this will be a good first step. I see Hanan is here from Morocco. So glad to see you here, Hanan. Charles is here. Welcome. Saisri is here. Danielle is saying that they made it through week 1. Christian is back from Mexico. Welcome. Noor is here. Welcome, Noor. Venkat is saying thank you for the course. So glad you enjoy it. I see a lot of folks from Lagos in Nigeria. That's wonderful. So this is the beginning of week 2. Welcome, everyone. Oop, give me 1 second. I just need to connect something. Okay. All right. So glad to see so many wonderful students here. I said that we would continue with the mini project, so I think we're definitely going to do that. I see Chen Vin is here from Saigon. Welcome. So glad you could be here. Joyce is correcting my pronunciation. Legos. Legos. Tell me if that's better. I see Chung Yen is here from Hanoi. Welcome. Amrendra is saying that last time we were working on the IP mini project. So that's what I'm going to start in today. If you have other questions, please put them in the chat and I will try my best to get to them. Lagos, Lagos. Thank you, everyone. I'm having a hard time pronouncing Lagos. Brian, if you're not seeing my picture, you might need to leave and restart the video. Okay, so I'm going to go to, let's see here. Are we in Python or data wrangling? I think it's in Python. I can't remember. I'll go to mini projects and then I'm going to go to IP. And the next thing I'm going to do is I'm going to restart and clear output so that I have a clean notebook that we're working from. I see Brian is in Thailand. Welcome. And let's get started with this mini project. And I see we also have people joining us from Dar es Salaam in Tanzania. This is amazing. So the first thing I'm doing is I'm going to run the first 3 cells. And it's always important to make sure before you start your mini project that you've run the from static grader import grader cell. That might be the most important thing. And then the other thing that we did is that we came up with our formula for doing Mersenne numbers. We came up with our thing for Mersenne numbers. We looked at ways to make a list, different ways to make a list, and then we came up with this wonderful function for determining whether a number is prime. And then we also came up with a function that used a list comprehension to get all the primes between 3 and 65. So if I were to create a new cell here and just look at Mersennes, I have the 17 numbers that I need in order to put into the grader. And I'll run it through the grader. So we finished exercise 1. We got a 1.0 on the grader. And now we are going to move over to question 2. And Brian says that I always make them want to have a cup of coffee. I know. Well, it's early in the morning here. Well, kind of early. It's 9 o'clock. 9 o'clock a.m. in California, so I always have my cup of coffee. Also, in case I get dry in the throat, it kind of helps me. So I'm sorry for anyone where I'm making them want a cup of coffee. Okay, so let's think about what we want to do in our Lucas Lemmer exercise. So the first thing we want to do is we want to test whether a prime number, a Mersenne number, excuse me. So the numbers that we made, I'm going to scroll up using our Mersenne function. We want to test whether those numbers are prime by using the Lucas-Lemmer test. So we want to write a function that generates a sequence used in the test. So we'll be given a Mersenne number with exponent p, and then here we have essentially what it is that we need to do to figure out. So we need to write an exception that accepts the exponent p of a Mersenne number and returns the Lucas-Lemmer sequence up to I equals p minus 2 inclusive. And so we need the modulo operation. This is all doable. We can definitely do this. So what do you guys think the first step is? So here we have a formula, and it starts with n sub 0 equals 4. So how should we start? How should we start our function? What do you guys think? So John says that we should initialize our first number. So I'll call it n0. And remember that in Python, you can have numbers in a variable name, but they just can't start the variable name. So we're making a list, right? It returns a Lucas-Lemmer sequence up to, okay, so I want to have a list, and I'll make it a 4. So essentially, I'm doing what Philip is saying we should do, which is I'm initializing a list, and I have 4 as its first element. And in fact, let's not call this N0. Let's call this LL for Lucas Lemmer, because this is going to end up being an entire sequence. And then I see John is saying we should do some sort of for loop. So I'll do for n in what? What comes next, do you guys think? What should be the range of my for loop? I see David saying we should do a range. I love that idea. I guess the range will start at 1. And what will it go to? Now, keep in mind here, I'm seeing p minus 1 and p minus 2. So let's keep in mind that we want to make sure that we include p minus 2 in our range, which means that we need to go one above it. So we need to do p minus 1. So that will include p minus 2 as well. Like Haneen is saying, p minus 1. Okay, good. So after that, oops, after that, I know I'm going to append something to my list. But the question is, what is it that I'm appending here? I need to create this formula here in Python language. So how can I recreate this formula using Python? I see Haneen has got the whole thing here. Let's start little by little. So the first part I need is I need this n from the list here, and I need it to be the previous number. So I'm going to do LL, and this I minus 1, I'll put it right here, I minus 1, excuse me, and I'm also going to change this N to an I, just so it all makes sense. And then I need to raise it to the second power, so I need to square it, and then I need to subtract 2. And all of this, it looks like, has to go inside parentheses. So I'll take this part here. Let me just indent it so it's a little bit easier to see. I'll put this into parentheses, and then next I have mod. So I'll put a modulo, and then I'm going to have 2, and now I'm just following the equation, 2 to the p power minus 1. And then I will put, no, and then that's it. Yep, L minus 1, LL is 1. So this is the Python version of this. Now, Yahia is asking an excellent question. They want to know what that parentheses sign means. And let's take a second to look at that. I'm going to open up a new cell. And what modulo is it's modulo division or modular division. So I'm going to divide one number by another number. And whatever the remainder is, that's going to be the result of the modulo division. For example, if I have 9 and I divide it by 2, I'm going to get 4, but there's going to be a remainder of 1, because 2 divides evenly into 8, right? 2 times 4 is 8. 8 divided by 2 is 4. But if I do it by 9, I don't get an even division. I have that 8, and then there's a 1 left over. So 9 modulo 2 equals 1. So that's what this little percent sign means in Python. It's modular division. And if you're interested in learning more about modular division, here's a quick look from Wikipedia. And also, if you're interested in doing modular division in Python, here's a quick reference from Geeks for Geeks. And I see John is giving a great detailed explanation of modular division. So that's wonderful. Thank you so much, John. Okay, now after I get through this for loop, and by the way, here in append, you can see that I've broken it down into 3 lines. So I have my open parentheses at this first line, and then I have a extra line in the middle, and then a close parentheses at the end. It doesn't need to be here. I could actually put this all in one line, but I think it's a little bit easier to read if I break it up like so. But again, it's just a question of style. So it's whatever you feel works best. And then after that is all done, I will have my return, and I'll say return LL. So let's see if this works. I'm going to open up a new cell and just say, what if I did LL for 17? Oh, excuse me, I'm doing the wrong function name. So Lucas Lemmer 17. I definitely get a bunch of numbers here, so that's good. And with this in mind, I'm going to replace the current LL result assignment with Lucas Lemmer 17, and then I'll run this cell and I'll see how I do. And my score is 1.0. So it looks like this formula is ready to go, or rather this function is a good implementation. A good implementation of Lucas Lemmer. And I see Muthu has come up with a different idea for the range, where they have p minus 2 plus 1. I think that'll also work. It's basically just making it a little bit more legible. Yep. It really is up to you which way you want to do it. Hussein wants to know why they get a different result when they run their code. This is an excellent question for the forum. Make sure you post your code to the forum, and then people will be able to look at it for you and help out. So that would be my advice. So Calvince wants me to look at this particular part right here. So let's take a look at that specifically. And what I'm going to do is I'm going to take this whole bit of the function, and I'm going to start a new cell, and I'm going to paste it in here, and I'm going to just unindent it, and that way uh, I'll make p equals 17. There we go. So now I'm running the function, but outside of the function, so we can take a look at it. And the other thing I'm going to do is I'm going to split this cell. Okay. So the important thing to keep in mind here is that 4 is my n minus 0. So you can think of 4 as being in the 0th place of this list. For example, if I look at LL index 4, it'll give me 0. So this is the 0th place. And the way that this formula works is The next iteration of it, I'm going to start with n1, or rather, excuse me, this I, this sub I, first it was 0, next I want 1. And so what I'm doing is I'm taking the range and I'm starting it at 1, and then I'm going all the way up to p, all the way up to and including p minus 2. Now, when I look at this part, let's unpack this part here. So starting with the list, what I'm doing is I am accessing the items in this list. If I do this, there we go. Well, this actually won't work. Oh, excuse me. And so in the first iteration of this for loop, the I is going to be 1 because I'm starting with range 1. So if I do give me item at index 1 minus 1, I'm saying give me the item that's at index 0. So the first item. So it's looking for that item. And then once I have it, I'm going to raise it to the second power, which will give me 16. And then I will subtract 2, which will give me 14. And then once I have 14, I'm going to take that number and I'm going to modular divide. I'm going to modular divide it by, in this case, let's take a look at this. I'm going to comment this out so we can look at the second part. I'm saying give me 2 to the p, which we've defined as 17 minus 1. So that'll be 2 to the 17th minus 1, which will be some big number. And here I can say it's 131,000. And so now what I want to do is I want to take my 14 and I want to do modular division, dividing it by this big number, 131,071. And so I'll put the modular divider here, and it's going to give me 14 as the remainder. Ankit has a great question about data type. Can anyone answer? And I see John has answered. Thank you, John. So I have 14, and then once I have that 14, I'm going to append it to my list. So now I no longer have just 4 in my list, I have 4 and 14. And then in the next iteration of my for loop, my I turns in not from a 1 to a 2, which will give me 194. I see one person asking, how can this be 14? Good question. What I'm doing is I take the first item in my list, which is a 4. I'm going to square it, so raise it to the second power, which is 16. And then I'm going to subtract 2, which will make it 14. And once I complete this whole operation, I actually end up with 14, and that's what I'll append to my list. And then the next time I do this for loop, let's break this down here. I'll start with 14. I'll raise it to the second power, which is some big number, 196, and then I will subtract it by 2, and that'll give me 194. And then in the modular division, it's going to be that same constant, which is whatever, 130 something thousand. So that'll, again, have me end up with 194, and that's what I will add to the list. And I'll go so on and so forth all the way to until I get this big list that we saw previously, which is with all of these numbers. And if I look at my function, I can see at the end, I can see at the start, I initialize the variable LL. I initialize it as a list with one item in it. And then in my for loop, I add items to that list. I append items to that list, and then I return the list. So if I look at the type for LL result, it is a list. And a function can return anything in Python. I could return a string, I could return an integer, I could return a float. In this case, however, we're making it a list. It's returning a list to us. Okay, good. Other questions about exercise 2? Okay, so I'm going to move on. And for people that would like another explanation of this, I'll ask, remember that all of these office hours are recorded, and that way you can go back and listen to this as many times as you need to. Okay, so Chung Neun says that the next exercise is the difficult one. So let's dive into question 3. So far, so good. Let's go on to question 3. So we'll be talking previously about Mersenne numbers. And what we want to do now is we want to write a function that tests if a Mersenne number with exponent p is prime. And so we're going to, again, look at the Mersenne numbers between 3 and 65, and we'll see which one of them are prime. And we're going to create tuples where we're going to have the exponent, and then they'll either be a 0 or 1, indicating whether they are prime or not. So 0 would be not prime, and 1 would be prime. Okay, let me hear your guys' ideas. What are some ideas that you have for creating this function? I'm seeing lots of good ideas here. We're definitely going to use the functions we created. That's definitely true. I'm just looking at all these ideas. I'm sort of considering what is the best way to move forward. Now let's look at something here. Let's create another, hold on one second. I'm going to create an empty cell here. I want to go back to my Lucas Lermer test. Now, Lucas Lemmer, somebody give me a prime number. What's a prime number? A number that we know is prime. "31. 3157. Okay. Now, if I look at the last number in this list, it's going to be 0. In fact, let's take a look at, thank you guys, these are so many numbers. All right, so what I'm going to do is I'm going to, Lucas Lemmer, the function returns a list, and we're going to look at the last element in the list by using the -1 notation. So if I look at the last number for 31, I get a 0. If I look at 11, which is another prime number, if I look at 2, I get a 4. Okay, this is all very interesting. So let's think about this here for a second. So how do I know? Let's just take a look at this here at the beginning. This will be helpful for our thinking. It says, for a given Mersenne number with exponent p, the number is prime if the Lucas-Lemmer series is 0 at position p minus 2. That is to say, at the last part of the list, the last item in the list. So a Mersenne number with exponent p is prime if the Lucas-Lemmer series is 0 at position -2. Or excuse me, at position p minus 2, the last part of the list. So for example, if I put in 31, if I put in 17, I can see that the last item in the list is 17. If I put in 31, I can also see that it's 0. And so what I want to do is, the first thing I want to do is I want to test whether the last number in my Lucas Lemmer list is 0. So how can I do that? How can I decide whether it's, how can I test whether it's 0 or not? What do you guys think? So Aniket has the idea of reversing the list, and then Saud has another idea, which is I can I can use this same notation that I was using above. I can use this -1 indexer. So I can go to Lucas Lemmer P, then access the last element by using -1, and I check whether that equals 0. And I see some people doing -2. Remember that we're not talking about P minus 2 necessarily. We're talking about the last item in the list, which happens to be the P minus 2 version. But we're talking about the last number in the list. So it's Charles is right, it's index -1. So the first thing I'll do is if Lucas Lemmer, the last item in the list, equals 0, then I know it's prime. So I'm going to return a 1. And I can put else return 0. So if I run this function, ll prime 17, it should give me a 1. All right. If I do 31, it should give me a 1. All right. If I do 2, it should give me a 0. Okay. Now someone is raising a good point, which is that I don't necessarily need this else here. If I have this if statement and it's triggered, it'll be triggered, but otherwise it'll just be jumped over. And so I could also write my code like this if I wanted to save a line. So Gebert Nesse is absolutely right. So that's my LL prime function. Charles has a question about returning p minus 1, or excuse me, returning a tuple. And let's go on and just see how let's see how this develops. All right, so the first thing is I need prime numbers between 3 and 65. How can I get the prime numbers between 3 and 65? All right, I like Saud's idea. They're saying primes equals get primes, which is the function we made previously, 3 to 65. So if I look at primes here, here are all the prime numbers between 3 and 65. And so now I need to figure out which of these is correct. So let's see here. I'm going to go with, I'm going to call this prime tests. I'll make an empty list. And then I'm going to write a for loop for p in primes. And I'll do prime tests dot append ll prime p. And if I run this and I look at, so this is primes, print, I'll print primes, and then I'll also print prime, excuse me, prime tests. Okay, so now I have my primes and my prime tests, and I know whether they are prime numbers, excuse me, I know whether they're Mersenne primes or not, and I have them right here. And so now I just need to put them together. So how can I make this into those tuples that I want? Well, I can actually, let's see here, I can go zip, I can zip them together. So I can go zip primes and then prime tests. And I actually need to put this inside of a list so that it generates. And if I see that, here's what I get. This is beautiful here. And I'll save that as Mersenne primes. I'll delete this here, and I will also delete this line. And I'll run it through the grader, and I get 1.0. So that definitely works. So this is one way to do it. I did see, I believe it was Charles who had a question about why not just return a tuple? Let's try Charles's solution and see what happens. So there are many ways to skin a cat, as we say in American English. So let's see if we can do it. So I'm going to change this to return P and then 1, or return P and 0. And I'm going to comment all of this out. Whoops. I'm going to comment all of this out. So now, if I do LL prime 17, it gives me a tuple. If I do 2, it gives me a tuple, but this time with a 0. Okay. So what I could do next is Mersenne primes, and I could make it a list comprehension, where I could go LL prime P for P in primes. And if I look at Mersenne primes, I should get the same thing I had before. I think that looks right. Let's see what the grader says. And I still get my 1.0. So 2 options there. Depending on how you create your function, this is how you can either zip them together or you can use a list comprehension. Okay, questions regarding what we've seen so far. What do you guys think? So somebody is asking how this list comprehension works. Let's do it as a for loop, and that way we can, well, I mean, essentially, a list comprehension is the same as a for loop, although it's a little bit faster computationally. But let's just compare the different pieces here. When you're doing a for loop and you're putting things together in a list, you start with an empty list. If you're doing a list comprehension, you just kind of put everything inside the list that you want to create. So these two brackets at the start and end of this line are the same as these two brackets down here. So these brackets here are the same as these brackets here. And then with the for loop, where I have for p in primes, that goes here at the end of your list comprehension. And then whatever operation you are performing on those p's as you cycle through those variables, that's what goes here. So this operation goes at the start. This for loop goes at the end. And these brackets go at the start and end of your list comprehension. And that's how you put together your Mersenne primes. That's how you put together your Mersenne primes list comprehension. Now, Chenvin has a question about, is there any recommendation of math to perform these more effectively? Absolutely. And that's what we do in the remaining exercises for this notebook. Now, some of you guys may have noticed that for your prime number checker, it's kind of slow and it doesn't work very well with large numbers. And the reason is because we're checking every single number. So there is a faster way to do it, and it's using the math that is outlined here. So the question is, now we need to make a faster version of our prime number, determining whether it's a prime number. So let's begin that. I don't think we'll be able to finish, but let's start. And let's start with, let me scroll up to our first number, our first detector. And the first thing that we did is that if our number is less than 2, we return false. And then when we scroll down, I'm just going to copy and paste that back. So if number is less than 2, we return false. That stays the same. Precious says that when they want to grow up, they want to be like me. Everything except the hair. Okay, so let's see here. I know that if it's less than 2, it's definitely going to be not a prime number. John wants to know, how about beards? The beard is up to you. I like to think that I didn't go bald. I just moved all my hair from here to here. I had like a hair migration, a southern migration. Okay, so I know that if a number is less than 2, it's going to be false. It's not prime. And I also know that if it's more than 2, but it's also an even number, that is also going to be prime. Excuse me, that's also not going to be prime. So the question is, what do I do? What do I do? Let's put some notes here. Less than 2, not prime. And more than 2 and even number, not prime. Now I see part of that loop here. Apurva has put in some of it. I'm going to copy and paste it in. So if number is divisible by 2, excuse me, if it is divisible by 2, excuse me, yes, if the remainder is 0, then I'm going to return false. But you're right that there's something missing. I need to have an and, because I need to check whether it's more than 2. So first I check whether it's divisible by 2, and then I check whether it is more than 2. And if it meets both of those criteria, I'm going to return false. So here I have an if statement that has 2 parts to it. First check whether it's an even number, and then check whether it's more than 2. Okay, it looks like we've run out of time. Let me just add some quick links and things for you guys before we end the office hours, and we'll go on to the rest of this function tomorrow. I'm going to go to the Jupyter Hub landing page, and a few things I want to bring to everyone's attention. The first thing is video links. If you scroll down, you'll see that all the week 2 video links have been added. The office hours for this week and their times are posted. And then there's also a playlist where you can see all of the archived office hours. So if you want to see any of the office hours that we've had previously, you can use the link that I've just pasted into the chat. If you are having connectivity issues, I'm going to scroll up, and you want to download videos, you can go to the Video Downloads tab. This is a shared folder. And this is where you can find all of the videos to download. And if you want to access the Google Drive, I will copy and paste that here. And that link will take you right to the Google Drive folder where all of these videos are stored. Okay, that is it. So I am going to sign off. I will see everyone tomorrow. I hope you all have a good evening. I hope you've had a good start to the week. And I hope that everyone is ready for week 2. So I will see everyone later. I hope you all have wonderful days. And until we meet again, happy data science, everyone. Bye bye.